All right, ladies and gentlemen, welcome to your quiz review video. This goes right along with your notes that you have in your packet, so you can go right along and fill in your notes and prepare for your quiz that you have coming up. The first one is a warm-up here. It says use the table to graph the function. Remember, when we're doing this, we are inputting x values. Remember, that's our domain, that's our input, it's our independent variable. We're inputting x values into the function, and then we're doing some stuff. We're squaring. In the opposite, we're adding 5, and then we get our y values. Once we get that, we get a coordinate point that we then put on the graph, and then we go and graph the rest of those points. So when I'm doing this, remember, and this was shown to you in class, this was shown to you in other examples. Remember, I can't get rid of this negative here, right? When I substitute a negative value, there are actually going to be 2 there. That's what you see when I substitute in each of these. So first example, I'm going to substitute a -3 in for x. -3 is going in for x right here. It's negative, but then I have to take the opposite of that, right? So I got to take -3 and square it. Remember, that's -3 times -3. That gives me +9, but that negative goes along with it. So it's -9, and then I add 5. -9 plus 5 is -4, so I get the point -3, -4, which I'm now going to move some stuff around and go ahead and graph that. -1, 2, 3, -1, 2, 3, 4. Next, I substituted a -2. So -2 squared is -2 times -2, which is +4, but then the negative goes along with it. -4 plus 5 is 1. So I have the point -2, 1. So -2, 1 is right there. -1 squared, I get 1. Again, the negative goes along, so it's -1 plus 5 is 4. So I have -1, 4. 1, 2, 3, 4. 0, that's the easiest one. 0 squared is 0. 0 plus 5 is 5. So I have the point 0.05, which is right there. I'll do the same exact stuff with 1. 1 squared is 1. Again, I have the negative, right? So 1 is negative plus 5 is 4. So I have 1, 4. Points right there. For 2, I'm going to substitute in 2. So 2 squared is 4. Again, the negative goes along. So it's -4 plus 5, which is 1. So I have the point 2, 1. I'm going to go back up and graph that. So 2, 1 is here. And the last one, you guessed it, we're going to get -4 again. So 3 squared is 9, but again, the negative goes along. It's -5 plus 9, which gives me -4. So I have the point 3, -4, which is back down here. What you should notice is that we have this, this curve, right? This curve that goes up and then back down. And again, remember, whenever we have a squared function, right? Whenever we have a squared function, we will get a curve. And if you don't get a curve, that means you did one of 2 things. You plotted your points wrong, or you made a computational error. So go ahead and always check those. All right, next example here. Are these graphs continuous or discrete? So remember, continuous graphs are continuous graphs are connected points, and discrete graphs are unconnected points. So this one is continuous because there are no gaps in the points. And if we're going to answer the same question right away, this one will be discrete because it's got disconnected points. Now remember, when we write the domain and range for a continuous function, we have to use an inequality, right? We're either going like x is less than or equal to values and greater than or equal to values for the domain, right? Or the range, we're doing the same thing, but we're using y. And again, that's just saying that like y is in between the lowest number and the highest number, right? And x is in between the lowest number and the highest number. So when I look at this graph, the domain, remember, is the x. The graph goes from here to here, okay? So that's 0 to 8. So really, it's like I have 0 to 8 right here, right? And so that is my domain. My lowest number is 0. My highest number is 8. And this says that x is less than 8 or equal to 8. And this says x is greater than or equal to 0. That's what my domain is. Now for range, I do the same exact thing, but for the y. So my y goes down to 0, and its maximum value, I'm going to say that's about 45, okay? So it goes to 0, right? But then goes all the way up to 45. So then, like I said, that is my range. My minimum value is 0. My maximum value is 45, and this says y is going to be less than or equal to 45 and greater than or equal to 0. Okay, so remember, continuous functions, you have to write an inequality for the domain and range or it's not right, okay? It is impossible to individually list out values for a continuous function just because we have all those in between, right? So we have to have an inequality. Now, for discrete functions, on the other hand, it sometimes is possible to list out every single value, right? So in this one, if I'm going to do the domain, remember that's the x. And so what I do is I literally go to each point, right? And I say, okay, here's a coordinate point. The x, I start on the left and go all the way to the right. So for this, I'm like, all right, here's a point, and my point here is -6. So I list that out. Then I go to my next point, and I realize that that's 2. I'm going to move this. Then I go to my next point, and that is also, I'm sorry, I said 2, that's -2. Go to my next point, that's 2. Go to my next point, that is 4. Go to my next point, that's going to be 6. And I go to my next point, and I have 2 values here, right? This actually, remember, makes it not a function, but I only write values in the domain one time. I do not repeat them. So I'm only writing 1, 8. And then I do the same thing for the range, except for now it's obviously the y, right? So I go, again, I'm going to start low so I can get it in numerical order. So my lowest y value, I got this set up again. My lowest y value is -6. And again, I have that twice, but I only need to write it once. My next value is -4. I have that 2 times, but I only need to write it once. 0, again, 2 times, only write it once. And then I have +4 right there that I will write 1 time. Okay, so that is writing the domain and range for continuous and discrete functions. For discrete functions, remember, you literally list out all the values. For discrete, you have to write an inequality because listing it out is impossible. All right, next ones. Decide if the relation is a function or not. It's a function. If it's not a function, indicate why. All right, now in a table, these first 2 are in a table. When we're in a table, what we're looking for is repeated x values that pair with different y's, okay? So if I look at this, all of my x values, none of them are the same. This checks out. The first one is a function. That's okay. This one has repeated x values, right? And they are matched with different y values. That makes this not a function. And I want you to visualize this. So like pretend you were graphing that, right? So like, well, it could be over here. So -2, 6 would be here. -220 would be way up here, and that would fail the vertical line test, right? So that makes this not a function. And in the table, it looks like repeated x's with different y's. So this one is not a function. And it's because of, let me just make this a little more clear. It's because of repeated x's with different y's. So no, not a function. Okay. This one, now if we go to the graphs, now we're just looking at that vertical line test, right? Now if I put the line over here and I say, oh, look, it doesn't hit at all, that just means I'm bad at the vertical line test. You try to make it fail, right? So that's not good. We can make it fail right here. This fails the vertical line test. It hits twice. So this is not a function. This also, for the same reason, is obviously not a function, right? So this one is no, no. And this one does pass the vertical line test. There's no place it will hit twice. So this one is yes. Okay. Next question. Sarah has already sold $33 worth of tickets to the comedy show and sells them for $4 per ticket. Okay. She's already sold $33 worth of them and she sells them for $4 per ticket. So write a function using function notation to describe this situation. So remember, right? I want to write if I have a regular equation that's y is equal to like 2x plus 4, and I want to write that in function notation, all I'm doing is replacing that y with f of x. That's it. Right? And that just means like the function is now evaluated at some value x. That's all that means. So then I have, there's the regular 2x plus 4. This is now a function in function notation. If we want to do it for this scenario, my original equation could be y is equal to, and then I've already got 33 bucks, right? And I'm adding to that $4 per ticket. And I want to say that X is then representing tickets. I'll abbreviate that. X equals tickets. Maybe I should say number of tickets. I will say that. Number of tickets. And now if I want to write that in function notation, I replace my y with the f of x. So that's equal to 33 plus 4x. All right. What are the independent and dependent variables here? Well, the independent variable is, remember, is what is the x value. It's what's going into the function. It's your domain. All those things are the same, right? So the independent variable is going to be the number of tickets. And remember, that's x, right? My dependent variable, it's not exactly clear of what y represents, right? But we can make sense of, like, she's getting money, right? So maybe we can say that the dependent variable is f of x, right? Which means total sales. Or you could say amount of money collected or earnings, whatever you want to say there. It all represents, all of those things made the same. But you have to have something that, what that means. What does it mean, right? Now we want to look at a reasonable domain and range. And if I ask you for a reasonable domain and range, what I'm asking you is numbers that make sense for the situation, okay? So let's start with domain, right? Domain is what's going into the function. It's what our x represents. In this case, it's the number of tickets, right? Well, what are the possible tickets that I'm selling? Find a reasonable domain and range if I have 6 tickets left to sell. Well, if I have 6 tickets left to sell, I got to think about numbers that make sense for that scenario, right? Like 0.5 doesn't make sense because I can't sell half a ticket. Negative values certainly don't make sense because how do I sell a negative ticket, right? Does 0 make sense? Well, yeah, I can sell no tickets. That's not a problem. And I have 6, so it's really just going to be 0, 1, 2, 3, 4, 5, 6. That is my domain. That's the reasonable domain for this scenario. That's my domain, 0, 1, 2, 3, 4, 5, 6. And now my range for this has to match those domain values, right? What I mean by that is my first range value must be when x is 0, right? And if I go back to my equation, that means I'm substituting in 0 for x. So 4 times 0 is 0. And then I add 33 and I get 33, right? And then I sell a ticket and I add $4 more to that. 4 times 1 is 4, plus 33 is then 37, right? And then I sell 2 tickets, and you get the idea, right? All of these values have to match. And if they don't match, then it's incorrect. So I'm just going to annotate that a little bit. Okay, they all have to match. So these are my range values that match with that. Okay, then if you notice, it's just adding 4 each time because, well, every time I sell a ticket, I collect $4 more. So that's how you find the reasonable domain and range. All right, number 4, we got the taxi driver problem. All right, so Tom is a taxi driver. He charges $4 to pick up people, plus 50 cents per mile. What is the independent variable? Well, the independent variable is what's going into the function. So actually, it might make more sense to write the function in function notation first and then figure out what those things mean. I have to have function notation. I know I'm starting with an f of x, right? And that's going to be equal to, well, what? Well, I charge it's like somebody gets in the car, I charge them $4 right away. Boom, $4, please. And then I'm adding to that 50 cents per mile, right? So that's 50 times x. And I did that wrong. It's not 50, because if I leave it at 50, that means I'm charging $50 per mile. And you better hop out of that cab because you're going to be broke very soon. It's 0.50, right? 50 cents. Just make sure you're paying attention to the money there. All right, well, now that I got my function, maybe it's more sense to talk about what the independent variable is. Like, what does this represent? Okay, well, x represents miles. Miles driven, miles traveled, however you want to say it. It's the miles, right? The dependent variable. You can say this in a lot of different ways. It's f of x. It's like cab fare, right? How much you pay for it. It's your cost, total cost. It's your f of x, okay? Like, all those things will be okay. All right, so let's go through this. It says Tom picked up a passenger and drove 10 miles. What's the charge? Well, that just means that my x value is 10, right? And I substitute that in. So f of 10, that just means the function evaluated at 10. Just tells you I'm substituting 10 in. So it's a little bit more descriptive than just saying regular old y. F of 10 is equal to 4 plus 0.5 times 10, or 0.50. It doesn't matter if you have 0 there or not. I just evaluate this, right? So f of 10 is equal to 4 plus half of 10 is 5, right? So this means f of 10, the function evaluated at 10, which is 10 miles. So 10 miles is $9. Okay. Now we want to graph the function. I already have all the stuff entered here, but our function that we're dealing with is y is equal to 0.5x. And all I'm doing is substituting these x values in, getting y values, and graphing. So my first value is 2. So it's 0.5 times 2, which is 1, plus 4, which is 5. So I have 0.25, which is, according to my scale here, you might have a different scale, right? It's 2, 5. I should maybe take a step back here and say, like, when you graph, you have to have correct labels, right? And so your independent variable, your domain, your x values always go on the x-axis. Your dependent variable, what's coming out, your range, is always on the y-axis, right? So I just said miles and cost. You could have distance traveled in miles or fare or whatever, but it has to be labeled correctly. Also, scale is important, right? I'm actually just counting by ones here. But sometimes it doesn't make sense to count by ones because, well, you know, it might not work out. What if it costs hundreds of dollars, right? I don't have the graph big enough, so maybe I have to count by tens. Just keep that in mind. In any event, let's go ahead with the next point, 4. At 4 miles, I substitute in 4. 0.5 times 4 is 2. Add 4 to that, and I get 6. So 4 miles would cost me $6. So 4, 6 would be there. Then 10, we already did that. We know it's $9. So 10 is, 9 is right about, right about there. And then 18 would be $13. So if I substitute in 18, half of 18 is 9, plus 4 is 13. So I have 18, and then 13 would be right about here. All right. So that's what my graph looks like. And now I can use the graph to answer a question or two. Okay. So when I'm looking at this, it says use the graph to estimate the cost of a 3-mile ride. Something's not right about my graph here. I'm not really happy about this. 2, 5. I graphed the first point wrong. You guys were like, Mr. Vesbach, that's probably wrong. That's what I was pausing about there all that whole time. All right, so I graphed 2, 5, and I actually graphed 2, 3. 2, 5 is right here. Now everything makes sense because I have a nice straight line. All right, so sorry about that. That's the whole reason why I had that pause there. My bad. All right, so I'm going to go ahead and like graph this line. The reason I'm actually going to graph a line is because this is most certainly a continuous situation, right? You're not like warping and skipping distances. You don't automatically appear 2 miles away without going through all the in-between distance, right? So this is definitely a continuous situation, and therefore I have an actual line. Now, I will use that line to answer this last question here. But the cost, estimate the cost, and I want to get rid of this for a second. Get rid of that. The page. To estimate the cost of a 3-mile ride, and it says using the graph. Now, when we do this, right, I literally do not want you guys to substitute 3 into the equation and tell me what the answer is. I already asked you to do that 4 times in the table. What I want you to do is use the graph. The way we do that is and the way that I know that you've done it is by showing me that, look, I went to the graph and I found 3 on the x-axis because miles is an x value, so I go to 3 on the x-axis. Then I go up to the graph, and now I estimate what that cost is, all right? Now, it's an estimate, so an estimate can be a little bit accurate, but if you told me this was $8, I know that it's wrong. If you told me it's $1, of course that's wrong, right? So it has to be an accurate estimate. And I would say that if this is 6, that's 5, or if this is 4, this is 5, that's 6. I would say that's about $5.50. So we can say about $5.50. All right, so that is your quiz review. Hopefully that helped. Again, you can always go back and watch any of the other videos in preparation for the quiz. Do your best when you get there, ladies and gentlemen. I will talk to you guys in the next one. Peace.